The Snake River and Radiation Lab has discovered that the hydrogen bonds of some organic molecules provide a capacitor-like field between the covalent hydrogen electrons and the nucleus. Energy from the nucleus is projected through the hydrogen protons and stored in this field. This discovery is documented in the video, Part 2, the discovery of the alterable nuclear energy field. There is a form of radioactive decay which duplicates this capacitor-like exchange between energy from the nucleus and a single hydrogen electron. That form of radioactive decay is known as beta decay. Radioactive beta decay is associated with an isotope of hydrogen known as tritium. The tritium nucleus is composed of the one proton of hydrogen and two neutrons. Beta decay occurs when tritium hydrogen resides autonomously within a nucleus and independently decays to helium-3. The decay is accomplished by one of the neutrons of the autonomous tritium nuclear element converting to a proton. The energy of this decay is invested in an alterable and independent tritium capacitor-like field. For any beta decaying mass, the sum total of beta conversions of neutrons to protons is accompanied by ejections of beta electrons and gamma emissions. This creates a beta capacitor-like field. We can record these beta electrons and gamma emissions using a beta-sensitive Geiger counter. The decay events are time-stamped to determine frequency. We know this beta capacitor-like field exists because we are able to influence the beta field using an externally applied electrical capacitor field. An external capacitor field is applied to the atomic element. The nuclear material is integrated into a pole of the external capacitor. When the external field is turned on, the frequency of beta decay is increased. This is an important discovery because it shows that the half-life of beta decay is actually controlled by a common capacitor-like field shared by all the tritium nuclear elements. The time-stamped record from the Geiger counter provides the number of beta decay events for every second of the recording. The number of events per second is called the frequency of the decay events. We have grouped the frequency for each second into sets of 4 seconds and calculated the average for each set. Each of these sets is designated as a measure. The height of the bar shows the average frequency for each measure. Notice that the frequencies recorded under the 220-volt field are much higher than the frequencies of beta events recorded with no field present. The mean or average frequency under the 220-volt external capacitor field is 8.69 Hz. The mean frequency under the capacitor field is 172% of the mean frequency with no field present. The mean frequency with no field is only 5.06 Hz compared to the 8.69 Hz under the field. The difference between the mean frequency under the 220-volt capacitor field and the mean frequency with no field present can be tested statistically using a t-test for significance. The variance in frequency would occur less than 1 time in 100 by chance. This meets the scientific standard for significance.
At the dawn of modern science, Isaac Newton pointed out that experimental evidence should not be ignored and suppressed in favor of what he called the vain fictions of our own devising. Yet this is exactly what has occurred to our beta decay experiments. Strong experimental evidence has been suppressed in favor of what Newton called the vain fictions of consensus science. As the previous data graph illustrates, when a beta decaying radioactive material is integrated into the negative pole of a capacitor, the frequency of beta decay events is increased significantly. These beta frequencies are increased in direct proportion to the amount of voltage applied to the external capacitor. The greater the voltage, the greater the frequency increase. Multiple tests demonstrated these increases, and all increases were statistically significant. Yet these results cannot be reported in the scientific press. They have to be reported via public access video. Why? Consensus science won't allow for the results. There is nothing in this consensus nuclear model which would allow for beta decay to result from an autonomous tritium nuclear element. Just as there is nothing in the consensus model which would allow these autonomous tritium hydrogen nuclear elements to establish a common capacitance field, similar to the common capacitance field established by the hydrogen bonds of some hydrocarbons. What the consensus model disallows, the consensus model rejects as possible. Consensus science is willing to relinquish the evidence of experiments for their vain fictions. This suppression does not result only in the loss of knowledge, but the loss of an important control over nature. The most significant of the beta control experiments shows a method by which the decay can be suppressed by absorbing its energy directly into the capacitance field, and that this field energy absorption is accompanied by a huge power gain. The experiment shows that a nuclear power generator, which apparently doesn't consume fuel, is possible. However, this experimental result cannot be understood without first knowing how the beta decay distributes its energy.